Lesson 8 is talking about solving multi-step equations and inequalities. And just because these problems can take a while as you're going through them, for the most part, the examples we're not going to talk through. We'll just talk through the got it problems. So one thing you notice on example 1, though, is that there's distributive property on both sides. So you would distribute the 20 on the left side and the 15 on the right side. When you have that on both sides, you can't do that second method with dividing like we had talked about previously. Like this one as well, you wouldn't divide by 6 on both sides because there's 2 terms here, and so you'd have to divide this by 6 and that by 6. So in this case, you'd want to do the distributive property, where later on there's some questions like this where you could do it either way with distributing or with dividing, because there's only one term on that side. But if you're unsure, always do distributive property, okay? So here we have 12m plus 12 is equal to, this is going to be 18m plus 18. And as we work through, I'm going to subtract 18. That gives me 12m minus 6 is equal to 18m. Then I'll subtract 12m on both sides. And remember, at this point, you could have done any step. I started it this way, but you could have subtracted 18m, you could have subtracted 12m, you could have subtracted 12. So I have negative 6 is equal to 6m. To solve, I divide by 6 on both sides, and I'm going to rearrange it so my variables first, m is equal to negative 1. Well, when I try it, 12 times negative 1, that's negative 12, plus 12, that's 0. And here, 3 times negative 1 is negative 3, plus 3 is 0, times 6 is 0. So I know that answer works. It's a good solution there. It's the correct solution. On the next one, we have to distribute on both sides. So that's 5n minus 15, because 5 times a negative 3 is a negative 15. 3 times n is 3n, and 3 times 7 is a positive 21. From there, I'm going to add 15 to both sides. I get 5n is equal to 3n plus 36. I'm going to subtract 3n from both sides, and 2n is equal to 36. Divide by 2, and I get n is equal to 18. Well, 18 minus 3 is 15. 15 times 5, that's 75. 18 plus 7, that's 25. 25 times 3, that's 75. So I know my answers work here. Don't forget, when you get to this level, right across here, where you had 4 terms and you've gotten rid of one of the first terms. At that point, that's when you're looking for which ones your like terms are, and you're trying to get them on the same side. So at that point, that's where people try to do things like divide by 12, but you are moving them over. When you move something, like here I moved a constant, when I move it to combine like terms, that's an adding or subtracting. Here I was trying to get rid of the 6. The m stayed there. Getting rid of the 6, that's multiplying or dividing. Okay? So make sure you're not trying to divide or multiply too early. That's moving to combine like terms, that's add or subtract. Now, the bottom here says some equations have no solution. Here I had a solution of negative 1, here I had a solution of 18. Sometimes there isn't a solution. When this occurs, the solution is the null or empty set, and we use this symbol here to represent that. Other equations may have every number as their solution. An equation that is true for every value of the variable is called the identity. And that might be kind of confusing. It makes more sense after we go through some examples. So you have example 2, you have A and B both that you can look through on your own. And here's the got it's. So I'm going to distribute on this side. That's negative 6r and then minus 8, because a negative times a positive is a negative. 2 times 4 is 8. And on the other side, just for right now, I'm going to keep it the same. Now we need to simplify. I can combine my like terms. It's negative 6r minus 8 and negative 6r minus 8. At that point, you probably noticed something. I said negative 6r minus 8 on both sides. Okay? So that should tip you off of what our answer is going to be. But we still need to keep working just to prove it. So I'm going to add 6r to both sides. Well, that would cancel here, and guess what? It cancels there as well. When they cancel out with our variable and we get down to 2 numbers, if those 2 numbers are equal, that means the answer is all real numbers. Or the other thing you could call it is the identity. Okay? Either wording is fine with me. I tend to go with this one, but identity works as well. What that really means is I could plug in 1 for r and it would work on both sides. I could plug in negative 6 for r and they'll come out to be the same number on both sides. You can use any number you want. Every single number that you use will work. Okay? All real numbers will work. So here we're going to distribute 4 times 8, that's 32, plus 8w. Here I have 14 plus 8w. I'm going to try to move, notice not get rid of, move my variables to the same side. They actually end up both canceling out, so I have 14 is equal to 32. Those 2 numbers are not equal. 14 is not equal to 32. In that case, you're going to say the null or empty set, or, excuse me, or you could write no solution. Okay? Either one. Again, like here you could choose which way, here you can choose which one you put as well. I tend to go with the null set just because I think it's quicker, but either way works. Okay, the next one. You've solved equations like this. They work very similar for inequalities. So here, you could divide by 4 on both sides, but I'm going to change my mind and I'm going to distribute because 3 is not easily divisible by 4. So I'd have 3 is less than 4x plus 8. I'll subtract 8 on both sides, and I would get negative 5 is not or equal to less than 4x. Divide by 4 on both sides. I would get negative 1.25 is less than x. So when I rearrange it, remember, if I flip the inequality, I also have to flip the sign. So it would be x is greater than negative 1.25. On the next one, you could easily distribute, or since 72 you can easily divide by 4, you could do it this way. Remember, because there is 1 term on the side. You couldn't do it in problems like this because then you'd have to divide this by 4 and this by 4. You don't want to mess around with all of that stuff, okay? So I have b minus 3 is less than or equal to 18 because 72 divided by 4 is 18. I add 3 to both sides and I get b is less than or equal to 21. Okay? Remember, when you're checking, like on this one, greater than negative 1.25, you can't use that number. So I'd go the next greatest number. I know this sounds confusing with negatives, but it'd be greatest would be negative 1. Here you could actually use 21 when checking it, since it's an or equal to. We have some story problems. On this one, Mariella's parents have budgeted at most $575. So I already know my total is going to be about $575. At most means I can spend less than that, or exactly, just not over. For her quinceañera celebration, the cost of the party room is $75. How much can the family spend per guest on food if each of the 40 guests receive a $5 favor? So I like to think first, okay, what's my constants, what's my coefficients? So I know 75 is a constant. It's a one-time fee for the room. I also know each of the 40 guests get a $5 favor. And what I'm trying to find is how much can they spend per guest on food. So I'm going to say 40 people times F, F standing for the cost for food for each person. Notice mine looks a little bit different than theirs, but we're still doing the same thing. I started with my total on the other side, so I flipped the inequality. And what they did here is they had it before distributing. Mine's just, it's going to be distributed. Either way, you're going to come out with the same answer as this. So you can kind of follow along there. This one's a little bit trickier. So it says Sophia recycled 3 pounds less than the amount that James recycled. Hannah recycled 3 times the amount that Sophia recycled. If they recycled a total of 53 pounds, how many pounds did Sophia recycle? So on this one, how many pounds did Sophia recycle? That's my variable. S equals how much Sophia recycled. And just because of time, I'm not going to write that all out. I also need to find about James. And I also need to figure out what Hannah's is. So for Hannah's, that one's really easy. 3 times the amount of Sophia. So I'm going to put 3S. James, for them it says Sophia recycled 3 pounds less than James. So that means James did more than Sophia. So James did 3 pounds more than Sophia. Because Sophia did 3 less than James, so I have to have James having 3 more. Okay? We know our total is 53, and I'm adding up all of their recycles. So I have Sophia's, I have James, and I just reordered these, and I have Hannah's. From there, I'd combine my like terms. S plus 3S is 5S, plus 3 is equal to 53. I'd subtract my 3 on both sides. I'd divide by 5, and S is equal to 10. Okay? If they wanted to know exactly how many, you could always plug them back in. So James would be 13, Hannah's would be 30. Okay? And the last thing is distributing with inequalities. So on this one, I would distribute through. That would be negative 2k minus 2 is greater than negative 16 plus 5k. From here, I could start with any of them. I'm just going to add 16. So negative 2 plus 16, that's a positive 14. I have a negative 2k out front and a 5k here. I'll add 2k to both sides. So I have 14 is greater than, and this would become 7k. I divide by 7 on both sides, and I get 2 is greater than k. Now I'd have to rearrange. K is less than 2. Okay? Remember that you always need to rearrange, means you flip the inequality sign. The other time you would flip the inequality sign is if you multiply or divide by a negative. That's the one people tend to miss the most. Okay? Because of time, and this is kind of a long video already, we're going to skip 5B. If you have any questions on this, please let me know, and I will be glad to help you.